Right, welcome to the pH and pOH lesson. So after this, we should be able to explain the degree to which water auto-ionizes using its kW, and we'll explain what that means. And then also be able to find the pH, the pOH, the hydrogen concentration, and the hydroxide concentration. As a really quick side note on this right here, whenever you see brackets, it's the same thing as molarity. And remember, molarity is just big M, it's moles over liters. So concentration, molarity, they all mean the same thing. So whenever you see the brackets, it just means that it's how much moles of that solute you have within liters of the solution. So concentration, how much hydrogen ions or hydronium ions you have, and then how much hydroxide ions you have. The other side note I would like to point out is H plus hydrogen is pretty much analogous to, it's the same thing as H3O plus hydronium. And we'll go over why that is in a second. All right, so the auto-ionization of water. So if we look at water and we go ahead and write H2O, right? H2O ionizes just a tiny, tiny, tiny bit. Ionizing, remember, it just means you break up into the positive cation and the negative anion. And so there's two things. I'm going to go ahead and rewrite water as HOH, right? So H2O is what we're used to, but if we write it as HOH, it makes it a little easier to see. It auto-ionizes less than 5%, really tiny amount, right? So we're going to do that back and forth arrow. And it breaks up into hydrogen, because that's the first part, and then the second part, which is hydroxide. So it breaks up into that, into that cation and into that anion. Right, so hydrogen positive, hydroxide is negative. So that's what we mean by auto-ionizes. It likes to stay as water. It likes to stay as a whole molecule, but some of it does break apart into that positive and negative. If we go ahead and put two waters together, say we have H2O plus another H2O, one of them can act as an acid, one of them can act as a base. And what I mean by that is, let's say that this one water is the acid, this water is the base. This acid can donate one of the hydrogens over to this base water, and that base can then accept it. And so when we go ahead and rewrite it on the other side, we have the first water giving up one hydrogen, so it becomes hydroxide or OH negative, and then the second one accepted it, so it becomes H3O plus. So again, it's that ionizing, it's that negative, that positive. They're the exact same. The equation on the left, the equation on the right. The only difference is H plus versus H3O plus. And again, those are analogous to each other. They're pretty much the exact same thing. So water is water. Water is neutral. Water is an acid. Water is a base. And it auto-ionizes just a tiny, tiny bit. Now, in order to find the hydrogen concentration, the hydroxide concentration, and the pH and the pOH of pure water, we're going to go ahead and look at a couple of equations. So the first equation that I want to bring up is the kW equation. And the kW, so K, it just is an equilibrium. The W stands for water. So this is water at some equilibrium. And it's just the concentration of hydrogen times the concentration of hydroxide. And you can easily replace, remember, that hydrogen with hydronium. Right? And so you're just multiplying those concentrations together. Well, this right here, when we actually measure it out experimentally, it gives us a number that's 1 times 10 to the negative 14. And so we know that whatever hydrogen is, whatever hydroxide is, it has to equal this number. If I wanted to find half of that, because we know that this is 1, this is like, say, 1x, and this is 1x here, that means that we have 2x, right? We have a 2x equals 1 times 10 to the negative 14, which means that both hydrogen and hydroxide have to be the exact same for water. Right, so when we look for hydrogen and we look for hydroxide, they're the exact same amount because they are in water, right? It's a 1-to-1 ratio. And so when we divide this by 2, let's go ahead and divide this by 2. we're going to go ahead and get hydrogen equaling hydroxide, because they're the exact same, they're both X, and it's going to be 1 times 10 to the negative 7. So when we look for the pH of water, or the pOH of water, our pH is always 7, right? And it's because of that exponent right there. So we're going to go ahead and explain a little bit more in detail what each of those equations mean. If you have questions, write them down as we go through. All right, so this little chart right here helps us to go ahead and convert between one variable to another. And so on the top part right here, we have the concentrations of hydrogen, concentration of hydroxide. If we want to go back and forth between these guys right here, we use our kW equation. So our kW is our hydrogen concentration times our hydroxide concentration. And we know that this has to equal 1 times 10 to the negative 14, right? So negative 14. So if it's water, they're the exact same. If it's an acid, say like coffee, it's going to be a different ratio, right? Or if it's a base, it's going to be a different ratio. But if it's water, it's the exact same, half and half. If you're going from hydrogen concentration, how much hydrogens you have, to the pH on the pH scale, you're going to use two equations here. So we have the pH is equal to the negative log of hydrogen. That's our first equation. And then if we wanted to find the pH, the hydrogen concentration from the pH, we take the opposite of that. And the opposite of log, in this case, log base 10, is 10 to the negative pH. On the other side, it's the same thing. If we have pOH, or to find pOH, we take the negative log of hydroxide. And to find the hydroxide concentration, we do the opposite, which is 10 to the negative pOH. And then on the bottom, we know the pH scale is out of 14. And so pH and pOH, if we add those together, they have to equal 14. A couple things to point out right here, right? The kW, 1 times 10 to the negative 14th, and then this is positive 14, right? It's always out of that 14. So when we use logarithms, so negative log here, we're using logarithms to make really big or really small numbers easier to deal with. So instead of using 1 times 10 to the negative 14 or 6.02 times 10 to the negative 23, stuff like that, we're going to go ahead and take the negative log of that in order to make it positive. That's why we do the negative times negative. But then the log enables us to put it into a whole number. And so whenever we're using the pH scale, right, pH, we'll do pH down here. If it's equal to 1, 7, or 14, 7 is neutral, right? If it's less than 7, it's an acid. If it's more than 7, it's a base, right? And it goes 1 to 14 typically. Well, the 1 came from an exponent, and the 1 came specifically from 10 to the negative 1. So that negative 1, when we take the negative log of that, it gets rid of the 10, and then a negative times negative equals 1. Same with this one, right? So 10 to the negative 7, that negative 7, when you take the negative log of this, gets rid of the negative and the 10, it becomes 7. Right, so that's how we get these different equations right here. And we're going to go ahead and use them and for a couple different examples so we can practice how to use these. All right, so we have hydrogen concentration given to us. It's 1 times 10 to the negative 4. They want us to find the hydroxide concentration, the pH, and the pOH. All right, if we're given the hydrogen concentration, we have to use, we're at this top left corner, we can either find the pH or the hydroxide. We can't find the pOH first, so we can go down or we can go to the right. I'm going to go ahead and go down just because that one's a little easier to me. So if we're trying to find the pH, I know the pH is negative log of hydrogen, right? So I'm going to go ahead and plug that in. So we have negative log of 1 times 10 to the negative 4. So In our calculators, we're going to go ahead and plug that in. So we have 4 negative times, oops, let me redo that. So we have 4 where is it? Okay, so 1 times 4, there we go. 1, I'm sorry, this is not the calculator I'm used to, times 10 to the negative, okay, I'm just going to give up on your calculators. Go ahead and practice this out. It would be put in scientific notation, right, and then negative log within that. On your calculators, you're looking for the one that says log. I can't figure out how to put scientific notation into my computer calculator. I apologize. If you didn't have a calculator and you're trying to figure this out, this part right here, 1 times 10 is 10, and anything to the log of 10 cancels out. So we basically end up with negative times negative 4, right? And so we end up with 4. So our pH in this case is going to be 4. Confirm that on your calculator, make sure that's correct. All right, so now we have the pH, we have the hydrogen concentration. We can find hydroxide or pOH next. I'm going to go ahead and find pOH next, just because that one seems, again, easier to me. So we have pH plus pOH equals 14. So right now I'm on the bottom of this, so I have my pH. I'm going to go ahead to the right and find my pOH. If I have 4 as my pH, and I'm trying to solve for my pOH, I'm just going to subtract 4 to both sides. Right, so when I subtract 4 to both sides, I end up with 10. So my pOH is 10. And then the last part I need to find out is how much hydroxide do I have? And so my hydroxide is going to be OH minus in brackets, so that's the concentration of it, and it's going to be 10 raised to the negative pOH. Right, so we're going to plug in 10 to that pOH because that's what we just solved for. So we have 10 to the negative 10. If you plug this into your calculators, and please do plug this into your calculators, you will find that it's 1 times 10 to the negative 10. And our concentrations, remember brackets, it's going to be molarity. Right, so anytime you see brackets, that's concentration, means molarity, moles over liters. All right, let's do 3 more examples. So we have hydroxide concentration this time. And so this time we are given the top right of our thing, and we need to find the hydrogen concentration, the pH, and the pOH. So we are on the top right. We can go down to find the pOH, or we can go to the left to find the hydrogen concentration. Since we went and found the pH last time, instead of finding the pOH, I'm going to go ahead to the left this time and find the hydrogen concentration. So I'm going to use that Kw formula. All right, so I know Kw and 1 times 10 to the negative 14, they're the same thing. It just means how much water auto-ionizes. And so if you want, you don't have to write the Kw part. Right, we just care about this part. So we're going to go ahead and keep concentration of hydrogen there because we're trying to solve for that. But for hydroxide, we're going to plug in 4.5 times 10 to the negative 6, which is equal to 1 times 10 to the negative 14. If this is being multiplied here, we're going to divide that to both sides. So we're going to divide 4.5 times 10 to the negative 6 to both sides. And in your calculators, you're going to go ahead and take this number and divide it by this number. Right, so I'm going to do it on my calculator that I have here on my desk. So we have 1 times 10 to the negative 14 divided by 4.5 times 10 to the negative 6. And that gives us 2 times 2.0 times 10 to the negative 1, 2, 3, 4, 5, 9. Should be 2.0 times 10 to the negative 9. Alright, so that's our first answer. Alright, the next one is pH and pOH. So we're going to find the pH by taking the negative log of 2 times 10 to the negative 9. If I plug that into my calculator, I'm going to go ahead and plug in 2 times 10 to the negative 9 logarithm. I end up with 8.7. I'm going to go ahead and round it. So my pH is 8.7. If it's greater than 7, remember that it is in base, and if it's less than 7, remember it's an acid. So in this case, the pH is greater than 7, it's 8.7, and so it's going to be basic. And then to find our pOH, we know that pH and pOH added together equals 14. So we have 8.7. And so we're going to subtract 8.7 to both sides, and when we subtract 8.7 to both sides, we end up with 5.3. So our pOH is equal to 5.3. All right. Last two examples, we have the pH this time, and so in this case, we're starting at the bottom left. We're trying to find both concentrations. We don't have to find the pH, but we do need to find the pOH. And so here, let's go ahead and go in order. So let's find the hydrogen concentration first. So hydrogen concentration, if we go from pH to hydrogen concentration, it's 10 to the negative pH. So we're going to plug in 10 to the negative 8. When we plug this into our calculators, we get 1 times 10 to the negative 8. And remember, it should be molarities because concentration, the brackets, it should be a molarity. So that's our first answer. Our second part is hydroxide. And so hydroxide, we're going to go ahead and find it by multiplying the hydrogen concentration to the hydroxide concentration, and that should be equal to 1 times 10 to the negative 14. So we know that hydrogen is 1 times 10 to the negative 8. We're trying to solve for hydroxide, and we know it should be equal to 1 times 10 to the negative 14. We're going to go ahead and divide the 1 times 10 to the negative 8 to both sides. Right, so we're left with hydroxide on the left, and when we divide that in our calculators, or we use our scientific notation rules to divide, we end up with 1 times 10 to the negative 6. Alrighty, and then the last part is our pOH. And so if we want to find our pOH and we know our pH, plus pOH equals 14. We know that the pH was 8. So I'm going to subtract 8 to both sides, so the pOH should equal 6. Alright, last example. If the pOH is equal to 11.22, we want to find each of the other variables. So in this case, we're starting at the bottom right of our chart, and we're going to try to work our way around. Alright, so the first thing I would like to do is find pH. And again, there's no right or wrong way of where to start, or where, as long as you look at your chart, whatever corner you're in, you can go, to the side or vertically, horizontally or vertically. You can't go diagonally though. So pOH is 11.22. We're trying to find our pH. So if we subtract that to both sides, we end up with 14 minus 11.22, which is 2.78. Cool, so we found our pH. The next thing I want to find, since I have my pH, is hydrogen concentration. So let's go ahead and find our hydrogen concentration. So hydrogen concentration is simply 10 to the negative pH So in this case, we have 10 to the negative 2.78. Whenever there's a decimal, you need to plug it into your calculator. If it's a whole number, it's usually just 1 times 10 to whatever that number was. But in this case, since it is a decimal, it's not going to be 1 times 10 to the negative 2.78 because you can't have a decimal within your exponent. So we're going to go ahead and plug it into our calculator. So 10 raised to negative 2.78 gives us 1.6, I'm going to go ahead and round it, 1.66 times 10 to the negative 3, negative 3. Alrighty. And then the last part would be our hydroxide concentration. And since I've already practiced showing you the Kw equation where you divide it, I'm going to go ahead and do this equation, which is the same as what I just did for hydrogen, but this time it's for hydroxide. So hydroxide is equal to 10 to the negative pOH. And so we have 10 raised to the negative 11.22. So we're going to do the same thing. We're going to plug that into our calculator. We go ahead and put 10 raised to 11.22, negative 11.22. And we end up with 6.03 times 10 to the negative 12. And there you go. In summary, if you have different concentrations of pH and different concentrations of hydrogen and different concentrations of hydroxide, it gives you a different pH or pOH, right? So this is a visual right here to help you out. So here we have more hydrogen. If we have more hydrogen, it's going to be an acid because hydrogens, if you donate hydrogens, if you increase your hydrogens, it's an acid. On the right-hand side, we have more hydroxide, and so that has to be a base. In the middle is where they're equal to each other. When they're equal to each other, they're neutral, right? So acids are more hydrogens compared to hydroxide. Bases are more hydroxides compared to hydrogens. And when they're equal to each other, that's where it's neutral. Whenever you have something that's neutral, the pH is 7. If your pH is 7, that means your pOH is also 7. Because remember that the pOH and the pH have to equal each other. Sorry, not have to equal each other. They have to equal 14. Right? So 7 plus 7 is 14. If you have a pH of 1 or maybe 3, for example, right? Anything less than 7, you have more hydrogens. The hydroxide concentration is usually just 1 times 10 to the negative, whatever that exponent was. You can do this as long as it's a whole number. The moment it's a decimal, you have to use your calculator. Same thing with this one, right? 1 times 10 to the negative, whatever your pH was, and it's to the negative 3. Right? 1 times 10 to the negative 7. Say this is 9 and 14. Right, so this would be 1 times 10 to the negative 9. 1 times 10 to the negative 14. All right. As far as hydroxide and pOH, it's the same thing but the opposite. And so what I mean by the opposite, if we have 7 is neutral for both pH and pOH, and we have less than 7 is an acid on the pH scale, that means more than 7 is going to be an acid on the pOH scale. So 13 plus 1 is 14, and then we have 11 plus 3 is 14, right? So should really make this 13 over here. And then we have on this side, anything less than 7 is going to be a base on the pOH scale. And so we have 9 plus 5, and then we have 1 right here. Right, so I just made up some random numbers, and it would be the same thing, same idea. You just take 1 times 10 to the negative 13, 1 times 10 to the negative 11, right? It's the same idea as up above, but it's the opposite, right? So pH is often what is most commonly used because it's easiest to understand. because anything less than 7 is an acid, anything more than 7 is a base. pOH scale is the exact same thing, it's just the opposite. So instead of less than 7, now it's more than 7, and then as an acid, and then less than 7 as a base. I tend to use the pH scale. It just makes my life easier. So I know 7 is neutral, acid, base, right? If you have questions, write them down, ask me them. Good luck.